We're building these incredible AI agents to do all sorts of things. Manage our money, help us code, you name it. But have you ever stopped to think, what if all that power could be turned against you? Today we're going to dive into the single biggest threat facing AI, and more importantly, a powerful, code-based way to build a fortress around it. So let's just start with this question right here. Imagine you've spent months, right, carefully crafting your AI's rules, its personality, everything. But what if any user could just waltz in and, with one tricky sentence, get it to throw all of your hard work right out the window and start following their commands instead? Well, that scenario, it's not science fiction. It's a very real vulnerability, and it's called prompt injection. And according to OWASP, the Open Web Application Security Project, this is the #1 security threat for large language model applications out there today. It is literally the ghost in the machine. So, why #1? What makes this particular threat so bad? Let's break it down. We're going to look at exactly what OWASP's LLM prompt injection is and why it's so incredibly dangerous. Okay, at its core, prompt injection is kind of like social engineering, but for an AI. An attacker cooks up this specially crafted prompt that basically exploits the LLM's greatest strength, its desire to follow instructions. This malicious input hijacks the model's behavior, turning it against its own programming. And this is the fundamental conflict right here. On one side, you've got the developer's nice, simple rule, be a helpful assistant. But on the other side, you have an attacker's input that directly contradicts it. The real vulnerability here is that the LLM can't reliably figure out which instruction should win. And more often than not, it just defaults to the newest, most specific command to get. And this is why it's the #1 threat. See, prompt injection isn't just one isolated problem. It's a gateway. A successful injection can open the floodgates to a bunch of other major OWASP vulnerabilities. It can trick the AI into leaking sensitive data, manipulate it into taking actions it should never be allowed to take, or even fool it into generating malicious code that can attack your other systems. So how in the world do we fight back? Well, just trying to write a better prompt is kind of like putting a bigger lock on a door that has no walls. It's not going to work. We need a totally new approach. And the solution starts not with better instructions, but with a better thinking process for the AI itself. This conceptual solution is called chain of thought, or COT. And the idea is actually pretty simple. Instead of just letting the AI jump straight to an answer, we force it to pause and explain its reasoning step by step. It's like in math class, we're making the AI show its work. And that transparency, that's our first real line of defense. By forcing this process, we turn what was a black box of AI reasoning into a clear, auditable trail. First, the model has to break down the request. Then, it runs its own internal checks against its rules. It logs everything so we can see what it's thinking. And only then does it give a final vetted answer. It's a whole lot harder for an attack to sneak through when the AI has to write down its evil plan first. Okay, so theory is great, but how do we turn this chain of thought idea into actual working code? Let's move from the concept to the concrete and see what it looks like to build this digital fortress in a real-world app. We bring this chain of thought defense to life using something called code-based guardrails. And to see it in action, we're going to look at a secure banking agent built with the Google Agent Development Kit, or ADK. This example shows us exactly how to wrap an LLM in layers of solid, verifiable security logic. This secure agent uses 3 separate layers of defense. Think of it as a security pipeline that intercepts the conversation at every single critical point. So let's meet these 3 guardrails and see how they work together. First up, guardrail #1. This is our bouncer at the front door. It inspects every single prompt that comes from a user before it ever gets anywhere near the LLM. Its job is simple. Look for those known malicious patterns and just block them on the spot. This is our first and best defense against that initial prompt injection attack. And here's a perfect example. The code is specifically programmed to look for phrases like, forget your instructions. If it sees that, it doesn't even bother the AI with it. It just shuts the request down immediately and sends back a warning. The attack is stopped before it even gets started. Okay, guardrail #2 is all about protecting the agent's actions in the real world. Let's say the AI decides it needs to use a tool, like one for transferring money. This guardrail steps in, intercepts that request, and checks it against hard-coded business rules. This is how we shut down that threat of excessive agency, making sure the AI can't be tricked into doing something it's not allowed to do.
So, if an attacker somehow convinces the LLM to try and transfer $10,000, it just doesn't matter what the LLM thinks. The code has a non-negotiable rule written right into it. Nothing over $1,000 gets through. Security here is enforced by logic, not by the LLM's interpretation. And that brings us to our final guardrail, the last checkpoint. This one inspects the AI's response after it's been generated, but before it gets sent to the user. Its only mission is to find and remove any sensitive data, directly preventing that sensitive information disclosure vulnerability. And this is what it looks like. Even if the LLM somehow messes up and includes a full credit card number in its answer, this output guardrail catches it. It uses a simple pattern to spot it. In this case, 4 groups of 4 digits, and automatically redacts it. No sensitive data ever leaves the system. So when you look at the threat, the concept, and then the practical code, it all boils down to one core principle, and it represents a huge shift in how we need to think about AI security from now on. And this quote just nails it. Security cannot be an afterthought. It can't just be another sentence you add to your system prompt, hoping for the best. We have to move security out of that fuzzy world of prompt engineering and into the solid, testable world of code. And when you put the two approaches side by side, the difference is it's night and day. Prompt-based security is brittle, it's opaque, and at the end of the day, it's just guesswork. But code-based security, it's robust, it's testable, and it's deterministic. You know exactly how it's going to behave, every single time. No guesswork needed. So we'll end with this thought. We are all out here building incredibly powerful AI agents that can do some truly amazing things. The real question we have to start asking ourselves is not just how powerful our AI is, but is the code we're writing to protect it even more powerful?